Okay, y equals e to the a. Oh, that's nice. What's e to the 0? 1 minus 1 is?
0.
So this one starts at 0, and it just kind of goes up like this. What does it look like on the other side? It levels off, right?
It,
Yeah, because
approaches but
That'd be
never
1 over
equals.
yeah, so there's a horizontal asymptote, right?
Yeah,
And what is it?
negative.
So you could kind of go like this if you wanted to, right? So what's it going to do? It's not a very good curve, but I'll leave it. Y equals x squared minus x. What does that factor into? X times?
X minus 1.
So what does that cross? It crosses at
0.
0 and 1. So let's say it's right there. Is it concave? Is it up or down?
Up.
And x, and it's going around what?
No, it's not.
Oh, it's bounded by x equals 1? Are those the bounds?
Yeah.
Oh, is this just an area?
Yeah.
Oh, that's nice. So is this it right here? Nice.
Yeah.
So we have this to there. Okay, that's nice. What are we going to be integrating with respect to?
X.
X. Very nice. And what's the leftmost or lower limit of integration?
0.
And it's going to go to
1.
1. What's the upper bound?
E to the x minus 1.
E to the x minus 1. And what's the lower bound?
X squared minus x.
There it is. So, do you guys? What is that What does that quadratic factor into? What's it factor into?
0 and 2.
Well, it factors into x minus 2. So it just gives you an idea of where you are or what you're looking at here. Girls at the back. Shh. Right there. And then at what, 2? And then what's sine of 0?
0.
It's not a very good symmetry on that, is it? Better.
Perfect.
That's
You wanna
not
look
bad.
About the spot between the,
Yeah. So it goes 0 right there.
Mhm.
And then what happens at 1? What's sine of pi over 2?
1,
1. So it goes up, and then it's 2. What is it?
0.
0. So it's going to go up all the way to 1 and then come down. So it goes up and then down. Is that the good shape right there? Not
Yeah,
bad?
but your definition of like 1 kind of very.
Yeah, I know. The scale is different on each side of the y-axis. Sorry. So is this integrating with respect to x or y?
X.
And it goes from 0 to
2.
2. And what's the upper bound?
So,
Sine of pi x divided by 2. And what's the lower bound? X squared minus 2x. And it's in terms of
X.
x. So you evaluate that. Anybody have an answer? What'd you get, Brad? What's your bid? What do you got? A line? No, yeah. See, that would be an answer that does not mesh with what we're supposed to get. That's correct. So we know that the y-intercepts are a and negative a. So what direction does this go in? Does it go? Do these parabolas go up or down?
The first one, the top one goes up. And the
Yeah,
second
it goes down. Good job. So you have
They go
these
away
two.
from each other.
They go away from each other. I like that. That's good. So you have this, and you have this, and you have this, and you have this. Nice. Not bad. Not bad if I do say so myself. That's good. We corrected our mistake. Nice. So we know that we're at A right here. So we go over H to here. So this distance right here is H. And now we have x equals A plus H. And what are we rotating this around? The y-axis. Hey, conveniently, we have already drawn the mirror image, right?
Yeah.
That's kind of nice. Okay, you're not as excited about this as I, but that's okay. That's fine. So what shape do you want to draw here? Do you want to draw washers or shells?
Actually, washers.
Washers are going to be easier in this case. At least I think so. Because this isn't a function.
Actually-
You would have, well, it depends on how you define ease and what you think is what's more challenging. I think washers is going to be nicer here. We'll see. Let's try it.
Yeah,
Let's try washers, and then we can try doing shells.
Yeah, I mean, like.
You're still going to have to do some
Yeah,
isolation.
yeah.
Yes, you're still going to have to do some isolation. So let's say you have this, and it goes like this. There are your pieces right there. Nice. Okay, so are we going to be differentiating with respect to x or y?
Why?
Yeah, it's perpendicular. These washers are perpendicular to the y-axis. The thin part is with the y-axis. So we have to go from here to there. It's going to be symmetric, though. So what could we do? Meaning, everything above the x-axis is going to be the same as below. Do you agree with that?
Mhm.
So what can we do
2
for
times
2 times whatever we have from what to what? 0 to, we need to find the y value right there. How do we find the y value right there? We want the positive one, so we're integrating to the square root of, what was it? 2ah plus h squared.
This is gonna be interesting.
Well, when you see something ugly like that, at least what I think in my head is, maybe it'll help collapse something later. Sometimes plugging in that, let's say, it might cancel out with the same thing later.
Right.
Okay, so now though, we're using washers, so what do we need? Pi on the outside, and then it's going to be big R squared minus little r squared, and it's going to be dx or dy. Very important to write that in so you remember to write everything in terms of y. What's the easier radius to get here, the big R or the little r? Which one's easier? One of them stays the same. Which one? How about answer that question first. Big R is easier. Why is big R easier?
It's a constant.
It's a constant. In this car, big R is what?
Big R is
A plus H. Ooh, wait a minute. That's the...
Oh.
Wait a minute. We have to be careful. Don't... Oh, it doesn't really... Oh, it's a constant, so it doesn't really matter, right? I was thinking in my head, oh, it's an x value because x is equal to A plus H. But it's the radius, the big radius is a constant. It doesn't change. So you can just write A plus H.
Right.
I was thinking in my head we might have to convert it, but do we?
No.
No. Little r in this case, what do we have to do for little r though? Solve it for what? Solve it with respect to y, exactly. Are things going to start, hopefully are things going to start canceling? Yes. So we have this 2ah plus h squared, and inside we have a squared plus 2ah plus minus a squared minus dy. What cancels? The a squareds cancel, leaving you with 2 pi integral from the 0 to the square root of 2ah plus, and then we have 2ah plus minus, and that looks nasty, but here's the thing. What's the only variable that's in there?
Y. And
Y is the only one that's in there, right?
you get 0.
Do you get 0? I really hope you don't get 0.
Well, substitute in.
We have to integrate
yeah,
first.
yeah.
Don't forget you have to
Yep,
integrate.
yep, yep.
Yes, I see what you're saying. You're about to get all happy like it's 0, and we've managed to create 0 volume from something that exists. It's a problem.
I'm like, there's a.
No, yeah, it's a problem. So it's going to be 2 pi times, and what is 2ah plus h squared y minus 1/3 y cubed from 0 to... Do you see what's going on there? Look. These are constants, right? So you can think of that blob as 7. What's the integral of 7 with respect to y?
7y.
Exactly. This is just a constant, so what do I tack on to the outside to get the integrate? Okay. We've just integrated with respect to y, so all we've done is tacked on that y. That's it.
Yeah.
So now it's just a matter of value. But nice. What's nice, though, is what's our lower limit of integration?
0.
0. 0. Is that what we hoped would happen? Did it nicely collapse? Yeah, so we're left with 4 pi over 3 times 2ah plus h squared to the 3/2. That's kind of cool. It's in the first quadrant, which is always helpful. They seem to be a fan of the first quadrant, don't they?
They should do it in the first one.
Y equals x cubed. So it's going to go up and then go. So here's y equals x cubed. Y equals 8. Let's just make it right there. Y equals x cubed. That's nice. About x equals 2. Where is x equals 2 if this is 8? What point is that? What is it? 2 comma 8. Exactly. So luckily, does it overlap itself? No. Luckily, it does not overlap itself. You guys don't like things when they overlap themselves. We've never done one like that. We talked about it a little bit. What do you have to be careful of if it overlaps itself?
You have to subtract.
You have to subtract the double counting. Exactly. You really don't. So here we go. So I did a decent curve there. There it is. There's your two sides. Now, here's your choice. Do you want to do washers or shells? Which one do you want to do?